Hello, today I'm looking at M3 International A-Level January 2014. This is question 7. So I have this rather strange diagram, and it says a smooth, hollow, narrow tube of length L has one open end and one closed end. The tube is fixed in a vertical position with the closed end at the bottom. A light elastic spring has natural length L and modulus of elasticity 8 mg. The spring is inside the tube and has one end attached to a fixed point O on the closed end of the tube. The other end of the spring is attached to a particle P of mass m. The particle rests in equilibrium at a distance E below the top of the tube as shown in figure 4. Find E in terms of L. Okay, so I can see this is testing me on Hooke's law. So the very first thing that I'll do is just draw a quick diagram of the forces. So I know that the weight is going to act down. Now the mass was m, so therefore the weight will be mg, and then what the spring will do is try to go back to its original length, so there will be a tension upwards, and for the tension I can use the formula lambda times the extension over the natural length. So lambda is the modulus of elasticity, so 8 mg, the natural length is L, and the extension is what they've called E. And in this position, then I know that there is no acceleration, so forces up equal forces down. So if I do Newton's second law vertically, then I get 8 mge over L equals mg. So I can divide both sides by mg, and to get E, I will multiply both sides by L. That's a 1, so I'm doing L times 1, and then divide both sides by 8. So here, this is the first 2 marks. I've worked out what E is. Okay, the particle is now held inside the tube at a distance of half L below the top of the tube and released from rest at time t equals 0. Prove that P moves with simple harmonic motion of this period. So I need to remember that when I'm trying to prove simple harmonic motion, I need to ignore the distance that it's moved initially and just say that it's displaced x from the equilibrium position. That is because I'm trying to get to the formula minus omega squared x equals x double dot. And so if I don't have a general position x, then I'm not going to be able to end up with this kind of thing. So that's what I'm aiming for. Okay, so what is going to happen then? I'm going to have the force downwards of the weight, mg, and then the spring is pushed down, so therefore the tension will try to push it back up again, and the tension is going to be lambda over L multiplied by the extension. Now the extension is what E was, and I'm just going to call this extra bit that it's extended L. Now, then I know that it is accelerating, so I'm going to have x double dot. So I shall pop that on my diagram as well. Now, in this case, I've chosen to measure x as the displacement down from the equilibrium position, so therefore x double dot should be measured down. So I've got forces down minus forces up equals the mass times the acceleration. Okay, I can divide everything by m, and then let's see what I get. So here I end up with g. Multiplying this out, the 8's cancel, the L's cancel, so I'm left with minus g, and then I get minus 8g over L x equals x double dot. Okay, so you'll see that these two bits cancel out with each other, but that just makes 0. So here I get minus 8g over L, x is x double dot, which proves that there is simple harmonic motion because it's in this form, and omega will be the square root of whatever this thing says, 8g over L. Okay, so that is worth 6 marks. Then it says the particle passes through the open end of the open top of the tube with speed u. Find u in terms of g and L. Well, let's just get these distances clear. So the top of the tube is here. The bottom of the tube is here, and that position was called O. It was initially compressed to half of L, so it began here. I know that E was L over 8, so let's just pop that in there. So this part here is L over 8, and so this is where the equilibrium position is here. So it began from here, it's moved up here, and so actually it's extended a little bit beyond this. So L over 8 kind of beyond the equilibrium position if we're talking about when we're here at the top of the tube. Now, so basically they want the speed at that point. Okay, so I can use v squared is omega squared a squared minus x squared, where v is the speed that they're talking about. Now they called it u, so here I'll put u squared. Omega squared is this thing squared, so I get 8g over L. A is the initial, will be the length from here to here, so it's like how much was it moved away from the equilibrium position when it began moving in this case. So I know that's L over 2, so A is going to be L over 2 minus L over 8, and so I know that's going to be 3/8 L. So then I need to square that to pop it in here, so I get 9L squared over 64 minus x squared, and here I'm interested in the value of x. Now I said x was measured from here downwards, and so here the value of x is negative L over 8. Okay, so that gives us u squared is, right, here I'll just stick all of these fractions in my calculator. So I've got 9 over 64. Subtract, when this is squared, this will give me L squared on the top and 64 on the bottom, so 1 over 64 I'll type in, and then that's going to be multiplied by 8, and so I just get 1 here out of this, 1L squared. Oh, sorry, without the 8 because I've multiplied it by 8 already, so I get 1g L squared over L, and the L's, one of the L's cancel, and so I get u is the root of GL. Okay, now, oh, hang on a sec, just looking backwards, sorry. Here we are at B. It said prove that P moves with simple harmonic motion of period 2 pi blah blah blah. Now here I ended up with the value of omega, but I didn't actually say what the period was. So I need to use the formula. T is 2 pi over omega, and so there I'm going to get 2 pi multiplied by the reciprocal of this. So there I get L over 8g. Okay, so that's important because that was part of the answer that they wanted here. Okay, so now I've also done part C, and I found that value of u, which is this, root GL here. And for the last bit of the question, it says, find the time taken for P to first attain a speed of this. Okay, so here, if I'm interested in speed, well, I'm looking for the time and the relationship between the time and the speed. Okay, so I need to use x is a either sine omega t or cos omega t. Now, because the motion began from the extreme, as it were, so from A away from the equilibrium position, then I need to use cos omega t, so that when I put t as 0 in here, I'll get cos of 0, which is 1, and so I get x equals a. Okay, so that's here. So then I can differentiate this with respect to t, so I'll get x dot, and here I'll get cos differentiates to negative sine omega t, and using the chain rule, this bit differentiates to give me omega, so I needed a omega. Okay, so this gives me the relationship between the velocity and the time. So now they told me that the velocity that they were interested in was this, so I can pop that in for x dot. So I have the square root of 9 GL over 32 equals negative a, and a was 3L over 8. Omega was the square root of 8G over L. So this is just reading off these values from earlier on in my work. Sine omega is this again, 8G over L, multiplied by T. Okay, so now I just need to rearrange this. So root, okay, let's pop the root L up here, so I get an L here and an L here, so basically all of these L's will cancel. And then I will get, I've got a root G and a root G on both sides, so I can divide through by that. Here I've got root 8 divided by 8, and so that's going to give me a root 8 on the bottom, which then ends up on the top over here. So on the left hand side I'm going to get a 9 and 8 times by 8 on the top and a 32 on the bottom, and the 8 will cancel with the 32 to make 4. Okay, then I've got this 3 here, or negative 3, and so I've got negative a third outside of that, and then I'm left with sine that stuff. So then if I square root this, I get a 3 there, which will cancel with this, and then I get square root of 4 on the bottom, which becomes 2. So I've basically got negative half is equal to sine of blah blah blah. And so rearranging this, then I'll do inverse sine to get this of negative a half, and I need to make sure my calculator is in radians there. And then I would get root 8G over L here. So then if I pop that on the other side, then basically I need to multiply both sides by the reciprocal of this to give me T. Okay, so then I can say that T is L over 8G multiplied by the inverse sine of negative a half. So I have inverse sine of negative a half, and that gives me negative pi over 6. Now, of course, time can't be negative, so let's just try and process what this answer actually means. Now, if I look at what my diagram shows, so x, I measured in this direction. I began from here, so it's going to first reach the speed going upwards, in fact. So this is why I'm ending up with a negative time here. So actually, if we want to use this, then x dot, really I should make this x negative, then x dot, the velocity will become positive, and then that will sort out all of these issues, because then I'll just get pi over 6, which is positive. Okay, so this is to do with the fact that I chose x to be measured downwards, whereas if I chosen for it to be measured upwards, then all of my signs would have come out correctly in the first place. But the velocity is in fact upwards in this direction, and so when I put in this value, this said it first attain a speed of this, but really, actually, I should have put I should have put this in to be negative. Okay, so whether you adjust it by changing this, or whether you adjust this by changing this to something negative, either way, you will end up with that positive value of t. Okay, so here I got t is pi over 6 L over root L over 8g. Okay, so that last part of the question is worth 4 marks. So altogether you've got 16 marks altogether. I hope you found the solution helpful. Do click like if you liked it, and good luck with your revision.